So this video is going to go through part of the process of balancing equations, and it's going to look at one of the things that you need to understand to be able to balance equations, and that is the idea of being able to count atoms that are in compounds. So an example of that would be if we have the common compound of H2O. Okay, we need to be able to identify how many hydrogens are there in this compound and how many oxygens are there within this compound. And what we're going to use is we're going to use two different things to help identify how much is there. The first thing is a subscript, and a subscript is something that indicates the number of atoms that are within the actual compound. So the subscript here would be 2, and what that's going to tell me is the subscript always goes with the element that is listed in front of it. So H2, meaning that there are 2 hydrogens in the compound. Now, there is not a subscript right here, right? But there could be a 1, right? But we don't write the 1. It's implied by simply having the element there. So because there is an oxygen right here, actually get rid of that there, right? Because there is an oxygen right here, what that tells us is that there is at least 1. So with this, there's going to be 1 oxygen in that. So in terms of counting how many atoms there are 2 hydrogens and 1 oxygen. A second idea that we have to understand with identifying the atoms in a compound is something called a coefficient, which a coefficient is going to tell us the number of compounds that are actually present. So if we again have H2O, but instead we make it 2H2O, so that means that there are 2 H2O compounds. What we're going to do here is we're going to identify how many hydrogens, how many oxygens. So if an H2O looks like this, here's my O, 2 H's, right? And again, that would be 2 hydrogens right here and here, and 1 oxygen right here. If I have 2 of those compounds now, what that would tell me is that would look something like this, where I have my oxygen there, oopsie, and then 2 hydrogens there. So what I'm going to be able to do is I'm going to be able to use this coefficient to identify that basically I'm going to distribute. I'm going to distribute this 2 to both of my subscripts. So I'm going to distribute it here to that 2. I'm going to distribute it here to the 1 that's written there or is implied there. So 2 times 2 would be 4. So I would have 4 hydrogen, 1, 2, 3, 4, and I would have 2 oxygen, 1, 2. So the coefficient is going to distribute to every element that's in the compound, and basically you're going to multiply however many there were with only a single compound. Now that we have 2, we're going to double each of those. So a few more example problems dealing with this and some other situations that you could come up with would be NaOH2. So identifying the different compounds here, because there's no subscript here, so that tells me that there's only 1 sodium. O and H. I have no subscript here, so that tells me there's 1 oxygen, and then I have a 2 right here after the hydrogen, so that tells me that there is 2 hydrogens. So 1, 1, 2, what that would look like. Now, if I wanted to do another one, I could say 4 NaOH2. What that would mean is that I would have 4 of those compounds. So if I'm identifying how many elements or how many atoms I have of each element, again, I'm going to distribute this 4 to every single subscript that is written. Okay? And so I would have 4 sodiums, 4 oxygen, and 8 hydrogen, due to having 4 of these NaOH2s. If it was 1, 1, 2, with 1 of them, with 4 of them, I'm going to have 4 times the amount, so 4, 4, and 8. Another scenario you could run into would be something that you have in parentheses. So again, NaOH2, but I'm going to put a 3 here. And what that would indicate is that I would have 3 of whatever is within the parentheses. So it's not that there's 3 of everything, but there's 3 OH2s. So I'm again going to follow the distributive property here, and I'm going to distribute this 3 to both the oxygen and the hydrogen when I'm counting the total elements within the compound. So again, sodium, oxygen, hydrogen. If I look at that, there's going to be 3 times, or excuse me, there's just a 1 here, so that tells me that there is 1 sodium, right? 3 times 1 for the oxygen is going to give me 3, and 3 times 2 for the hydrogen is going to give me 6. Lastly, if we put everything together, so we're going to have the compound 4 NaOH2 3. I'm again going to follow the same rules where I'm going to be distributing. Typically what you're going to do is you're going to distribute the 3 first, and then you would distribute the 4 through the entire thing. I would distribute my 3 to my oxygen and the 3 to the hydrogen, and then I would distribute the 4 to both the sodium, the total of oxygen, and then the total of hydrogen. So going through that, my sodium, because it's 4 times 1, would simply be 4. For my oxygen here, I'm going to do 3 times 1, which would be 3, and then 4 times 3, which would be 12. So I would have 12 oxygen. And then for the hydrogen, again, I'm going to distribute everything. So I have 2 hydrogen to begin with. I have 3 of OH2, so 3 times 2 is 6. And then I have 4 NaOH2 3s, so 4 times 6 would be 24. So again, if you look up here, this 4 simply indicates that I have 4 of these right here. So if I had 1, 3, and 6, I would have to multiply each of those numbers by 4. That's distributing the 4 to each element. So 4 times 1 is 4, which is there. 4 times 3 is 12, which is what I get there. And then 4 times 6 is 24. So if we can do the compound with just a single amount, having a coefficient out in front is something that is just going to tell me how many more I would have of each of those. So one thing I forgot to mention, if you go back to the notes that you wrote down here, is that the subscripts cannot change. So you are not allowed to change the subscripts that are within a compound. That, when it is written, is basically set. So subscripts we cannot change, whereas coefficients are things that we're allowed to change. And when we get into balancing equations, these are the things that you're going to be changing in the equations. Because changing the coefficient just changes the amount that you have. It doesn't change the thing that you have. So changing the coefficients is allowed when we're doing balancing equations. So next video is going to show the process that we would go through in balancing actual chemical equations.